Do you know that not just benzene, even the heterocyclic compounds like pyridine, pyrrole, thiophene and furan can be aromatic? Even the non-benzenoid systems such as cyclopentadienyl and cycloheptatrienyl charged species can be aromatic in nature. Yes, you heard me right. Just by looking at the molecule, you can easily recognize whether the compound is an aromatic compound or not, just by counting the number of pi electrons available in the cyclic cloud. Let's crack this once for all so that next time when you get a similar question in the GPAT or NIPAT, you can instantly answer that question. Once we look into the conditions for aromaticity, a compound should be cyclic in nature, then it should have conjugated system, that delocalization of pi electrons should be there continuously throughout the cyclic system, then it should satisfy Huckel's rule. When a molecule is meeting with all these criteria, then it can be considered as an aromatic compound. I have made a detailed video on aromaticity and Huckel's rule where I explained how benzene, naphthalene and anthracene molecules are considered to be aromatic. So all these details I have given in one of my previous video. The link for that video is provided in the description. Please go and watch to get the more details about aromaticity and Huckel's rule. Now let me explain how heterocyclic compounds such as pyridine, pyrrole, thiophene and furan act as aromatic compounds. So this is the structure of pyridine. So the structure of pyridine is analogous to benzene. So in case of benzene, the ring atoms, all the ring atoms are carbon. Whereas in case of pyridine, one of the carbon is replaced with nitrogen. So if you look at this molecule, the molecule is cyclic. So it is meeting with the first criteria. And here the molecule is having conjugated double bond systems. So here 3 double bonds are in conjugation with each other. So it is also meeting with the second criteria. Now if you see whether this molecule is obeying Huckel's rule or not, so the total number of double bonds available in this molecule are 3. So that means overall the number of pi electrons available will be 6 because 3 2s are each double bond accounts for 2 pi electrons. So thus overall if you see 6 pi electrons are present in the structure of pyridine. Okay, now when you equal 4n plus 2 equals to 6, we get n equals to 1. That means it is also obeying Huckel's rule. So this pyridine molecule is cyclic in nature, having conjugated double bond system, and it is also obeying the Huckel's rule. Thus, it is considered to be aromatic compound. So, in case of pyrrole molecule, this is the structure of pyrrole. Pyrrole is a 5-membered heterocyclic ring system having nitrogen as heteroatom. So, this molecule is also cyclic molecule and having conjugated system. So, you can see here pyrrole is having 2 double bonds. These 2 double bonds are in conjugation with each other. That means they are present at alternative positions. So, that means overall if you see 2 2s are 4 pi electrons are present in the structure of pyrrole. In addition to these 2 double bonds, at alternative position, the molecule is having nitrogen, where nitrogen consists of a lone pair of electrons. This lone pair of electrons of nitrogen are in conjugation with the double bond electrons. Thus, these 2 electrons also contribute towards the extension of the conjugation. So, that is how overall 4 plus 2 electrons, that means 6 electrons will be participating in the conjugation system. When the cyclic cloud consists of 6 electrons, then obviously the molecule is meeting with the Huckel's rule. So, that is how pyrrole is an aromatic compound. So similar to pyrrole, even furan and thiophene are also 5-membered heterocyclic ring systems. So in case of furan, it is a 5-membered ring having oxygen as heteroatom, whereas in case of thiophene, it is a 5-membered cyclic ring having sulfur as heteroatom. So in these 2 molecules also, 2 double bonds are present at alternative position. That means they are in conjugation. So overall, they accounts for 4 pi electrons. And now in case of furan, one of the lone pair of electrons of oxygen will be contributed towards the conjugation. And same is in case of thiophene, the lone pair of electrons of sulfur will be contributed towards the conjugation. And thus overall 4 pi electrons and 2 lone pair of electrons, 6 electrons are participating in the cyclic cloud formation. And that is how even furan and thiophene are also considered to be aromatic in nature. Now let us see in case of cyclopentadienyl. So this cyclopentadienyl is having 3 species: cyclopentadienyl cation, anion and corresponding radical. So how we can write its structure? So let us split the name of the molecule. Cyclopenta means 5 carbon containing cyclic system. So that is why I have written here a pentagon. Now it consists of a diene. That means 2 double bonds will be present. So this is 1 double bond and this is another double bond. Okay, both the double bonds are present in conjugation to each other. That means at alternative position. Now the first one is cyclopentadienyl cation. That means because it has loss of electrons with respect to one carbon, it gets positive charge. So this is how we can show the structure of cation. Okay, now if you look at the cyclopentadiene cation structure, so it is cyclic in nature. So it is meeting with the first criteria. Now coming to the conjugation, whether the conjugation is present or not, all the carbon atoms which are participating in the cyclic ring system should be participating in the conjugation. Okay, so with respect to the 4 carbons, if you see 1, 2, 3, 4 carbons, across these 4 carbons, 2 double bonds are present. But now coming to the 5th carbon atom, with respect to this carbon, highlighted carbon atom, there is loss of electrons. That is the reason it is bearing the positive charge. That means here there is no pi electron available. Okay, so if you look at the overall cyclic system, across 4 carbons out of 5, conjugation is maintained. But the conjugation has broken with respect to the 5th carbon atom. That's why there is no conjugation in this system. Okay, and also if you look at this particular cation, whether it is obeying Huckel's rule or not, that means if you count the number of pi electrons available, here 2 double bonds means overall 4 pi electrons will be available. In order to obey the Huckel's rule, the cyclic system must have 4n plus 2 number of pi electrons. That means either 6, 10 or 14 electrons should be present. But here, with respect to Huckel's rule also, the number of pi electrons are less. And that is the reason this cyclopentadiene cation is not aromatic. It is not aromatic. Okay. Now let's see in case of cyclopentadiene anion. So again, the same cyclic system with 5 carbons has been written here. Okay, and it is also a diene. So we kept double bond at alternative position. But it is an anion. That means one pair of electrons excess will be there on the 5th carbon, due to which this carbon we have given negative sign. Okay, because it is an anion. So now if you see this molecule is cyclic. So it is also meeting with the first criteria. Now coming to the conjugation, here with respect to 4 carbons, double bonds are distributed. So with respect to 4 carbons of this cyclic system, conjugation is maintained. Now looking at the 5th carbon is holding a pair of electrons, okay, which are present exactly at alternative position with respect to these 2 double bonds. That means even with respect to the 5th carbon also, due to the availability of pi electrons, conjugation is maintained or conjugation is extended. That means throughout the entire cyclic system, this cyclopentadiene anion, it is maintaining conjugation. So with respect to the second aspect also, it meets with the criteria. Now coming to the number of pi electrons, here overall 4 pi electrons from 2 double bonds are available. And with respect to the 5th carbon, 2 more p electrons are available. So that means overall 6 electrons are available in this particular cyclic cloud. That means it is obeying the Huckel's rule. And that is why this cyclopentadiene anion is considered to be aromatic in nature. Okay, now coming to its corresponding radical, again the same structure is written, cyclopentadiene structure is given. Now this is a radical. That means with respect to one carbon, there will be loss of 1 electron. How radicals will be generated from a neutral species? If one odd electron is losing, then that molecule generates a radical. Okay, so here 1 odd electron is shown with respect to one of the carbon. Let us consider 5th carbon. This is how we will write the radical structure. So if you look at this molecule also, it is cyclic in nature, but coming to the conjugation, the second important criteria, here these 2 double bonds and 1 odd electron which is present on the 5th carbon is in conjugation with the system, but that is not a pair of electron. Okay. And also whether the molecule is obeying Huckel's rule or not, if you see, as per Huckel's rule, molecule should be having, the monocyclic system should have at least 6 pi electrons. Okay. But here overall, if you see, 4 pi electrons are present and plus 1 radical electron is present. That means overall only 5 electrons are available in this particular cyclic cloud. That means it is not obeying the Huckel's rule, and that's why it is considered to be not aromatic. Okay, it is not aromatic in nature. So among these 3 species, that is cyclopentadiene cation, anion and radical, only cyclopentadiene anion is meeting with all these criteria. That is, it is cyclic in nature, having conjugation system, and also it is obeying Huckel's rule, and that is why it is considered to be aromatic in nature. So in case of cycloheptatrienyl also, 3 species we can write. It's cation, anion and radical. So if you look at the cation structure, this is cycloheptane. So a 7-membered ring is drawn here. Okay. and it is having triene. That means 3 double bonds will be present at alternative position. So that's why 3 double bonds were kept in this cyclic system at alternative position. Now this is a cation. That means with respect to the 7th carbon, there will be loss of electrons. That is the reason here positive charge is shown. So this is the structure of cycloheptatrienyl cation. Okay. Now if you see, this molecule is a cyclic molecule. Okay. So it is meeting with the first criteria. So now coming to the conjugation in this particular molecule, here 3 double bonds are present at alternative position. That means across 6 carbon atoms, we can easily make out the delocalization of the pi electrons. Now coming to the 7th carbon, it is having positive charge. Okay, but yet the molecule is having conjugated system and all these electrons are under delocalization. They are not localized bond, but they are delocalized bonds. How? Why it is so? It is because of the resonance phenomena. This molecule, even though I have given here one structure, actually resonance structures are possible for this particular species. So when you shift this double bonded electrons to the adjacent position to remove the positive charge from this particular carbon atom, then we will get this particular structure. If you shift the double bond to here, immediately this carbon will become deficient of electrons, so it attains positive charge. Okay, we'll keep the other 2 double bond positions the same as first structure. Now again, to remove the positive charge from this carbon, we can shift this double bond electrons, so that in the next structure, a double bond will be coming here, and so that the previous carbon, okay, where the double bond is present previously, that particular carbon becomes electron deficient. So it attains positive charge. We'll keep the other 2 double bonds position same in the newly formed resonance structure. So again, this particular carbon is bearing the positive charge and nearby it is having a double bond. So if you shift the double bond electrons to here, again, this carbon becomes electron deficient. Okay, so this double bond comes here and we keep the other 2 double bonds same as previous structure. And this is how we will get the positive charge on this carbon. Again, we can shift this double bond electrons to the adjacent position so that we get positive charge here. So that is how number of resonance structures are possible for the cycloheptatrienyl cation. So because of that means, even though when you look at one structure, it seems like the pi electrons are available only among the 6 carbon atoms, but because of this resonance phenomena, there will be delocalization of the electrons throughout the cyclic system. Okay, thus if you count the overall number of electrons, because 3 double bonds are present, only 6 pi electrons will be present, and that is how it is also obeying the Huckel's rule. So this particular species is cyclic, conjugation is maintained throughout the cyclic system, and it is obeying the Huckel's rule, and that is the reason this cycloheptatrienyl cation is considered to be aromatic. Now coming to its corresponding anion, here in case of anion, the molecule is cyclic in nature and conjugation is maintained. So 3 double bonds are there and a pair of electrons are present in conjugation with these 3 double bond system. So conjugation is also maintained. But if you look at the obeyance of Huckel's rule here, the cyclic cloud is having 8 electrons. Okay, 6 pi electrons are present and 2 lone pair of electrons which are present on the 7th carbon. So 8 electrons are present. Okay, that means it is not obeying the Huckel's rule. As it is not obeying the Huckel's rule, it is considered to be not aromatic. Same is in case of cycloheptatrienyl radical also. Here the molecule is cyclic, so what conjugation is maintained. So that is here overall 7 pi electrons are available. Okay, if you look at this particular system, cyclic system, 7 pi electrons are available. 7 pi electrons means it is neither 4 or nor 10 or 14 to obey the Huckel's rule. And thus this particular radical is not obeying the Huckel's rule. Hence it is also a not aromatic compound. So among cycloheptatrienyl cation, anion and radical, cycloheptatrienyl cation is aromatic in nature due to the presence of the resonance in its particular structure. So this cation is also known as tropylium ion. So this is how, just by looking at 3 criteria, that is whether the molecule is cyclic in nature, conjugated system is available or not, and the given molecule is obeying Huckel's rule or not, just by counting the number of pi electrons or the p electrons available in the overall cyclic system, you can easily make out whether the given compound is an aromatic compound or not. Let me know in the comments whether this concept gone deep or not, and if yes, then hit subscribe button and keep notifications on so that you will never miss my next coming chemistry concepts. Thanks for watching and stay tuned to my next videos.